So thanks again for everybody coming. And I will turn this over to the owner of Circuit Breaker Labs, Amanda, and she will be giving us a talk on how she creates her artwork.
Great, thanks for the intro. As Molly mentioned, I'm Amanda Presky, and I own a company called Circuit Breaker Labs, where the whole concept is that I'm transforming electronic waste into wearable art and gift products. So I am going to take you through why I even came up with this idea to begin with, the materials I work with, what I actually make with them, how I make them. So going through the tools and materials and processes and all the behind the scenes kind of stuff. And then, like Molly said at the end, I will take your questions. So I started selling handmade jewelry that I created when I was a teenager. And it was just, I always loved making things. And jewelry really stuck out to me because it's a really great nonverbal way of expressing yourself. And that worked for me as a very shy child. But art wasn't encouraged as a career. It was encouraged as an outlet. So I ended up going to school for chemistry. So all the while I was in college studying chemistry, making jewelry on the side. And then just by the nature of being surrounded by science and technology every day, I came across piles of broken equipment in the labs that had circuit boards and other electronic components. And the more I looked at them, the more I thought that they were really fascinating, especially if you condense them down into a small piece, like say a necklace versus like a whole board, becomes its own little world. So I started experimenting around with using at first circuit boards as a jewelry making medium. And then the recession hit. So I had a degree in chemistry, no likely prospects of getting a job anytime soon. So I thought the solution to that problem was going to grad school. So I got a PhD in chemistry, and all the while studying chemistry and making jewelry on the side, my business grew and grew and grew to the point where it was becoming its own thing. It had surpassed any stipends I was making as a student. And I realized that as a maker, I could actually make a career selling the jewelry that I was making. So the day I defended my thesis was also the same day that I became a full-time artist. And so Circuit Breaker Labs became my full-time job in 2016. So it's been 5 years, almost to the day, since I've been doing this, and I just love it. And the photo here shows an example of one of my booth setups from a few years back when I attended a maker fair. So I work with electronic waste, and this covers more than just computers. So of course, you've got your standard circuit boards. So I work with a lot of them. That's predominantly what I'm using in my work. Anything from motherboards, which are sort of the big powerhouses of your computer, down to what this top left photo shows, which are peripheral circuit boards. So things like graphics cards, hard drives, any other attachment that you would put in your computer, they tend to be smaller. I also use keyboards. So whether it's the keys themselves or the circuit boards within the keyboard. So the top middle photo shows both of those. I really love working with the keyboard circuit boards because they're transparent. So you can layer them over components and create a really neat layered three-dimensional effect. I also work with capacitors, resistors, diodes, hard drive platters. Those are things shown in the bottom left photo, and they are usually soldered to the surface of the circuit board or internal components in the computer. But in many cases, there's tons of these components floating around maker spaces that have been sitting for so many decades, they're not useful anymore. So I take them on and turn them into jewelry. I also work with a lot of wires. So the top right photo shows ribbon cable. This is typically used to connect components within an electronic system. So say a printer head to the printer's circuit board, you would need a ribbon cable to transmit information. But once you're done using the printer, you're left with a lot of really neat parts, including rainbow ribbon cables. I also use CDs and floppy disks. I have floppies in parentheses or in quotes because it's not necessarily floppy. So the picture I have here are 3.5-inch discs. They're actually quite rigid, but I'll use any form of memory disk in my work as well. And then finally, I also use silicon wafers and solar cells. So the bottom center photo shows a silicon wafer, and all those individual squares that you see on there will go on to become an individual chip on the circuit board. So before they cut them up and process them, they end up with these wafers. A lot of times there's defects in the manufacturing process, and then you're stuck with a wafer that you can't use. So I take those and turn them into jewelry as well. So my work encompasses a lot of different categories. I started off with wearables, so things like jewelry and accessories. And then when I upped my tool game, got a router and things of that nature, I was able to start making larger, more detailed pieces so that I could expand into categories like art and home decor. So here's some examples of jewelry that I've created using electronic waste. You'll notice a lot of them have this shiny coating, and it's called resin. I use a 2-part epoxy resin, and I really love working with it because it has a very high surface tension, sort of like a water droplet sitting on a table. So what ends up happening is that you get this domed effect that creates a lens. So when you're looking at the piece with a resin coating, it sort of looks like a snow globe, like it's got its own little world and reflections, things are distorted near the edge, and I think it looks really neat. So number 1 incorporates rainbow ribbon cable and resistors. 2 has the keyboard circuit board that I was talking about. That's the middle layer, the long vertical lines, resistors. And then the very bottom layer, which looks like gravel, is actually just a ton of really small capacitors piled on there. Working with electronic waste or circuit boards with the focus of my work means that when I'm out in public, people want to know what it does. Because usually you associate a circuit board with a function, like lighting up or having some sort of external function, something else that it does. But because everything I work with is upcycled, it doesn't do anything. It just looks cool. It's recycled. It's a repurposing of waste material. So number 3 was my creative attempt at adding function to a electronic waste piece by incorporating an actual flash drive. So it has a function, but it's also upcycled. 4 and 5 are my way around getting stuck with commercially available settings. So you notice a lot of these pieces are encapsulated in metal around the sides and the backside. Those are called settings or bezels. And because I'm a small maker, I'm at the mercy of what's available commercially. And so that sometimes feels really limiting with what I can do with the design. And one way around that is making my own. So example 4 and 5, I've used metal smithing techniques to solder metal together to create these new forms, different than what you can find commercially. So it adds a little bit more of me into the final piece. And then 6, 7, and 8 are fun combinations of electronic waste, and they all have components that hang down. So there's like a kinetic effect to how they wear, like things are moving around, which I think is a lot of fun. And so let's see, 1, 3, and 5 are more of those soldered pieces that I was talking about from the previous slide. This time they're in earring form. 6 really takes advantage of all the different colors of circuit board that I've been able to find over the years. Let's see, 4 and 7 are earrings that I created, not with circuit boards, but with other electronic components. So capacitors, resistors, diodes, things like that. And I really love combining them with other metal, industrial components, hardware, things like that to tie it all together. And then 8 is where I start to get really outside the box with what I can do. It's a pin that I made using my router, and I'll get into how that works later. So you saw all the different colors of circuit boards that I've used. It covers the whole rainbow, and those colored layers are called solder mask. The actual color of that layer isn't important, but the layer is. It protects the board during the manufacturing process from developing short circuits, fireproofing, things like that. But right underneath that is a layer of copper, and you can't see it when the solder mask is there. So if I'm very careful, I can remove that layer of solder mask, revealing this copper layer underneath. So all boards are going to have this copper layer. You may or may not be able to tell, but the solder mask still attached. So this is my way of unearthing that really neat copper layer underneath it all. And then I make a ton of small gifts and accessory type items. You'll notice a lot of these end up being circular, and that's by design. I find that because the resin does have that high surface tension that I was talking about, it tends to maintain that lens-like effect more effectively when it's around a circle. So if I try to put resin on something with hard corners like a triangle, it doesn't look as good. It looks shiny, which is a nice effect, but it loses that lens effect. And then another feature here, so the wine bottle stopper and the little pill box that I made are outside the bounds of what I can do by hand tools in terms of how precise I can get. So I use my CNC router to cut those shapes out. So I also make a ton of holiday decor, may or may not be for the holidays. So like the science ornaments and dinosaurs and things like that, I like to have them up year round. But the beauty of these is that once I got a CNC router into my making process, I was able to get a lot more detailed with the shapes and designs that I could make. So I love being able to make dinosaurs and atoms now. But I do have to be very careful about the designs that I'm making such that they are actually compatible with the limits of my tool. So what I mean is that the actual part in the machine that does the cutting has a width to it. So it limits the kind of details I can do and affects how small I can make things. So stars might look really great, large and blown up, but as soon as you get them really small, they start to look rounded and sort of flower-like. So I have to be careful if I'm designing something to make sure that I'm taking my instrument's limitations into effect. On the larger scale of from ornaments, the next step up is framed art. I've loved doing science themes, not only because of my background in science, but because I think using circuit board as the artistic medium, being so techy and with science, I think being so very dependent on our advancements in technology, it's such a great medium to show off science things. So I do a lot of atoms and rockets and hearts, anatomical hearts and brains and things like that with the circuit board. It's kind of like a cool double meaning there. I also make a lot of state and city country flags. So here I've got DC and St. Louis. I've started doing combining like common or up and coming themes like hand lettering, but do it with circuit board. So it's kind of a really funny interpretation because it's obviously not hand letter. It's very technical, but I think it looks really cool. I also do a lot of custom work, logos, state and city shapes, initials, anything like that. And I think this one project that I put on here, the heart that is red and blue, is a really interesting one. This heart depicts TGA, which stands for transposition of the greater arteries. It's a congenital heart defect. And I find that some families really like in their way of dealing with the problems that come along with it, art can help heal and bring people together. And so it was really neat to combine that with circuit boards to produce the heart piece there. And I alluded a bit to the different colors and the layers of circuit boards, but it actually took a really long time to get to this point. Perhaps one of the most difficult things about working with trash effectively is that I'm sort of stuck with what I can find. And it's taken years to build relationships with people who build computers or work in industries that have access to electronic waste that they want to get rid of. So it wasn't until a few years into the whole process that I was actually able to find a rainbow of circuit board colors. So like orange and purple are very hard to come by. And when I finally found my first orange board, I knew I had to make rainbows. And ever since, it hasn't been quite as difficult now that my network is pretty extensive and I do a lot of maker fairs where I meet a lot of people who work with electronics. But I love what it allows me to do in terms of creating with color, since otherwise I can't paint anything. So there's no real way to introduce color into what I do except by working with the colors that are already on the boards. So the bottom right photo, which shows the strips of color in the pendant, from a distance, people assume that I'm working with an actual rainbow circuit board. I really wish that was a thing I could do, but I can't. So my solution to creating these rainbows is to cut very precisely individual strips of each color from each color circuit board and then inlaying them together to create that one continuous rainbow. All right, so when it comes to making this stuff, There's no book out there that says this is how to make circuit board jewelry. So my way around working with the material and figuring out how to make it do what I want was by studying and combining tools that and techniques that woodworking and metalsmithing incorporate. So it looks a lot like a wood shop, but also like a jewelry studio if you were to walk around my studio. And so in terms of tools and materials, this is what I use to create everything. So I have a lot of computer controlled tools. So when I say CNC, computer numerical control, that means that the tool itself is being controlled by a computer. So I have a CNC router. The brand I have is called Carby. It's from a company called Inventables. I'll show more about Carby later because it's really the workhorse of my studio. I also have a CNC laser cutter. I have a Glowforge. Do not use it for cutting circuit board. It would be terrible. The things that you would, the dust that it would create, it's just not good. But I use it for creating other science products, as is my die cutter. Not something you can use with circuit board, but it's fun for creating other sciencey things. I also use a lot of manual tools. So my rotary tool, my Dremel, is probably my most used tool in that category. It's great for cutting down larger pieces into a more workable piece, or for trimming things down, making sure they fit in the bezel just right. It's really a tool that I use for perfecting the shape or size of the piece so that it works for what I need it to be in the end. And I also have a drill press, a miter saw, and a circular saw, all for different things, whether I'm cutting wood to build a display or chopping down a circuit board into a size that will actually fit on the cutting bed of my router. Building shelves for the studio, all that kind of stuff. I need them all. And then a lot of hand tools. So chisels, screwdrivers, things like that. I need them all, whether it's disassembling an old computer or putting something together. And I also use a lot of abrasives. So I count sandpaper and my tumbler in this category. Cut circuit board is gross, so it needs to be cleaned up. The tumbler works really well for removing a lot of spare bits and dust. And sandpaper is one of the key things that I use for fine tuning sanding. So if the Dremel is doing most of the work, the sandpaper is one last step just to get it just right. And then jewelry making. So if I'm making a jewelry piece, it's most likely going to have epoxy resin. So photo 1 shows my setup. I use a 2-part epoxy resin. So it's a resin and a hardener. They're mixed together in a 1-to-1 volume ratio. And I have this set up on a flat surface in a closet so that I can control the temperature and reduce the amount of dust flying around. You see there's 2 lamps there. They're used mostly for heat, actually, more than anything. I specifically source out incandescent bulbs, which are very inefficient at producing light because they produce a lot more heat than anything else, but it's perfect for resin. So if you've ever worked with resin, it's kind of a finicky material. You have to get the temperature just right so that the resin cures beautifully. Otherwise, if it's too cold, you end up with cloudiness. If it's too hot, you end up with an exothermic reaction where it's literally steaming and creates a degree temperature, which is perfect for resin. And by working in the closet, it's a small space. It's very easy to keep the whole area warm. So throughout the curing process, the resin looks really great. So once I've poured my resin, that's not the end of it. I usually keep an eye on it to make sure that there are no stray fibers or dust getting into the surface, which disrupts the surface tension. And then you can see on the surface where it's done that. It doesn't look great. And then also bubbles. So by keeping the workspace warm, it helps the bubbles rise to the surface and pop. But if they need an extra boost, I can use my torch to do that too. The heat from the torch helps release bubbles. And then the curing process itself takes about 24 hours to get to what's called a soft tack. So you can handle it without disrupting the surface, but you really shouldn't put anything else on it or put it, say, mail it out to a customer because it's not done curing yet. It could still get ruined. And then the work time itself is around 20 to 40 minutes based on how hot your resin is. So that's another reason temperature control is important, because if it's too hot, your resin will set up more quickly than you can use it, and then you end up with problems. So I lay out as many pieces as I can, knowing how much resin each batch requires. And then account for that in my temperature as well to make sure that things are the right temperature for a good cure, but also for getting everything done. So once the resin has gotten thick enough, so maybe we're an hour in, it can still form bubbles and the torch isn't going to fix it anymore. So I literally go in with a toothpick and scoop them out because bubbles just ruin the whole look. So number 2, photo 2 shows the torch setup that I have. I don't do a ton of metalsmithing, so I don't have a full oxygen tank torch setup. I just use a handheld butane torch. They're marketed as creme brulee torches, but they get very hot enough to melt silver, which is in like the 16 to 1800 Fahrenheit range. And you see I've got tweezers on there attached to a heavy base. Those are called third hands. So they help with holding things in place, literally a third or fourth hand during the soldering process, but they also work as a heat sink. So soldering is a very, very technical process and it's very dependent on heat flow. So your success with soldering is going to depend on your understanding of where heat is going and how to apply heat effectively to get the results that you want. So in this example, I have small jump rings that I'm attaching to a heart bezel. And it's really important to hold those jump rings in place with the third hand, just so the jump ring doesn't move around, but also to act as a heat sink. Because the jump rings are so small, a blast from the torch is enough to completely melt them. But because I've got them attached to the third hand, it helps with heat flow. So it disperses the heat a little bit more so that that jump ring doesn't get overheated. So that allows me to effectively solder the two pieces together without melting anything into a clump, other than the solder, of course, that has to get melted. And it's sitting on a black charcoal block, which is a really great insulator. It's sitting on a couple of other tiles that are heat resistant as well. So everything there is safely set up so that I don't ignite my desktop. And then 3 shows some of the pliers I use. Pretty much can't make much of any jewelry without pliers, basically used for manipulating metal. In this case, for creating loops on beads so that I can create those kinetic necklaces that I showed earlier. And I also use files for shaping the circuit board or trimming anything out of place. Yeah. And then 4, probably should have listed this as number 1 because it is the most important thing, safety. My background in chemistry is surely showing through here because I take industrial hygiene very seriously, especially given the nature of what I work with. And I say this as a PSA because working with circuit boards is really fun, but if you're going to try it at home, make sure you're aware of what you're getting into before you start anything. So as I mentioned before, the circuit boards have the copper layers, they have the solder mask layer, but there's also layers of fiberglass in between. So in the process of cutting circuit boards, if you're generating any dust, it's fiberglass dust, which is very similar to asbestos. So it's not something you want in your body, on your skin, around your house. So I have a bunch of different techniques and materials for navigating those hazards around the lab based on what I'm doing. So when I'm cutting circuit boards out in the open, I have a vacuum set up so that any dust that accumulates or is generated is vacuumed before it can even get into the studio. Of course, some gets out, which is why I also wear a face shield, goggles, gloves, an apron, all those sorts of things. And when I'm working with resin, the resin I use is supposed to be safe to use in a home setting, which I believe, but because of how much I use it, there is a chance that I could be accumulating those materials in my lungs. So when I do resin, like in the photo, I'm wearing gloves, I have respirator, and if my eyes were reacting, I would be wearing wearing goggles. So this shows my router, and this is how it works. So it starts with a vector file, which is basically an image, but it has some software behind it that basically says as you expand it, you don't lose resolution, which is really important if you want to cut something because you don't want actual pixelated marks in your final cut picture. So I start with this black and white image. Because I'm cutting all the way through the board, I use black and white to help the software identify areas where material is to be maintained versus where it's to be cut. If you wanted to use a router for 3-dimensional cutting, for example, if you used grayscale, that would indicate to the instrument depth of cut. But because I'm just cutting out the edge, black and white works perfectly for my process. So the software that came with my router converts that vector file to what's called G-code, and that tells the actual router what to do. It tells it how high to set the bit, how fast to spin it, where to put it on in relation to the piece that you're working on. And because it's computer controlled, you get extremely good quality and accuracy of your cut. So I am able to cut the top layer of windows in that Capitol building example uniformly and identically every time I do it. The margin of error is within like 1/10 of a millimeter. So it's pretty darn good for what I'm working with. So on the bottom right here, oops, I was not supposed to click that. So the bottom right shows the parts of the mill that move and what the software controls. So the top part there is called the spindle, and that can move in XY direction, so left and right, up and down, and then it can move in the Z-axis, which is, sorry, up and down, actually up and down. So it also controls the part that holds the bit. So those blue tipped metal pieces are the bits that I use for cutting. They're kind of like a drill bit, but they have a little bit more advanced machining based on what you're trying to do. So you can see there's little spirals going down. Those are called flutes. And you can choose the number of flutes based on what you're trying to cut, how much air or temperature control you want in your material. So when you're cutting metal, you'll choose a very different bit than if you're cutting circuit board or wood. It also controls the flow of cut material, where it's going. So as you're cutting, you're creating dust and particles, and they have to go somewhere, and you don't want them getting stuck in your piece and jamming up. So those flutes help funnel material up or down or both. I use what's called a down cut bit. So it has flutes that are shaped in such a way that material while you're cutting gets thrown down to the bottom of the piece. This works great because it means that the top of the piece I'm creating has really nice edges and clean cut lines. So you would change the bit that you use based on what you're actually trying to achieve. And then the bottom part, the beige platform there, will move in the XY left-right direction. So between all of these moving parts, whether the base is moving, the top is moving, both are moving, you can control through the coding where the bit is going so that you get these really precise cuts. I also have to be careful about cut speed. Unfortunately, because circuit board is a very tough material, I have to cut very slowly. Otherwise, if I go too quickly, I can break the bit, it can overheat, or the cutting itself looks more like tearing if you go too quickly. So as a result, the whole process of using the router is actually quite slow. And you'll see in the videos that I show in the next few slides, I've sped it up. Otherwise, it's quite boring to watch. So once I've got my cut piece, I'm not done yet. It doesn't always come out perfect because as the bits cut, they dull, and I've got to find a balance between replacing the bit and trying to make it work as long as I can. So what happens is as the bit gets really dull, it starts to tear through the board, and the little lines of copper start to peel up and shred on the edges. So after I've cut everything, I have an extensive cleaning and deburring process that makes them look really crisp and finished looking. And then it's time to add like a cord for the ornament, a necklace chain, or packaging if it goes in a box or something fun like that. All right, so here is the router in action. I believe this is a 5x speed. You can see the cutting bed's actually kind of small. It's only 8 by 12, but it works really well for motherboards because motherboards are just about that size most of the time. So what I'm cutting out here are wreath shapes. So they become these wreath ornaments that I make. And then instead of just finishing there and being done with it, I try to use as much remaining space left to make other things. So those teardrops become these earrings, or I'll cut circles to become cufflinks. The goal is to use as much as possible and create as little waste as possible. But if I do generate waste, or which is going to happen, there's always little bits left over, those go back to an e-cycler. So from them, I get stuff to work with. And then I also, when I'm finished, the pieces left over go back to them to be continued to be recycled. So here I'm cutting out a custom ornament that I made. So this is the cut file, the vector that I created, and then that got fed into the machine, generated the code, it cuts out the ornament, and then this is what it looks like. So a note about electronic waste. So just because a lot of people end up asking me this when they see me at events, if you have electronic waste sitting around, whether it's a laptop or an old mouse, cords, things like that, it's best not to throw them away. They really should be given to electronics recycler to handle properly. Not all electronic recyclers are going to do the right thing. So I suggest making sure that your recycled work or pieces are recyclable pieces are being brought to a R2 certified recycler. It means that they have to abide by certain standards set forth about how to recycle responsibly. And I highly encourage you to seek them out for recycling your old materials. Okay, so now I've got some sped up videos of doing epoxy resin. And this is, oops, sorry, there's some sound in there. This is what the resin looks like, and why I really love using it. It's because it's got that really shiny domed finish. And so this is the top view of laying out pieces to do resin. You can see me mixing it together, pouring it out quickly. And then the spacing between each piece is really important. I try to push the bounds of how much resin I can put in, because the more you get in, the higher the dome layer you have, the better the lensing effect is. But if you push it too far, you burst the surface tension and then it just drizzles down the side. You can see where some pools of resin have formed from prior pours. So this is also why I keep an eye on things, because I want to make sure if anything's leaking, I pull it away from the other material so that it's a contained accident. So if I have a leak, I'll just put it aside once it's cured, and then I can either add more resin, clean it up. Just like if I have a bubble, I can, once the resin's cured, it is fixable. I just carve it out, create a new open hole, fill it with resin again, and then it's good as new. So there's no reason to throw away anything that's been ruined, because really it's quite easy to fix. Right, so this is a really fun commission piece that I made for a customer who wanted to combine her husband's Mustang, cactuses, a skyline from Phoenix, and palm trees. And this was probably one of the largest, most intensive projects I've taken on. It was really interesting to make. So I recorded the time lapse, of course, the process. Once I had created all the pieces that I needed, assembling it all together. So this is assembled on a wooden panel, partially because I needed something really durable to handle the weight of the circuit board. And then I'm just using tacky glue to put it all together. It's a really, really great adhesive actually for working with circuit board, that and an E6000. So I use a lot of tacky glue because it's tacky and it sticks really well to the ununiform surface of the back of the circuit board. So you don't need a lot to get a really good adhesion. And you can tell that some of those layers are really stacked up on each other with barely any surfaces touching, and it works out pretty well. E6000 is another adhesive I use. It's really great because it's a little bit flexible, but it's very durable and it's very good at sticking pretty much anything to anything else, especially non-porous things. And circuit board is non-porous, metal is non-porous, glass is non-porous. So if I'm trying to stick all those materials together and I really want the piece to stay together, I don't want it to fall apart on a customer, it's a really great adhesive to use if you have to use adhesive. I prefer avoid using adhesive if possible, but it's not always possible. And sometimes glue joints are actually more sturdy than solder joints or cast joints. So it's a big part of my process in designing what I'm making, what its end use is going to be, how I'm going to put it together, what materials I use to make sure that it holds up long term. All right, I guess that was it. I went through that a little bit quicker than I thought I would. So I guess I'll talk about this photo here. I like doing overlays showing all various stages of electronic waste from waste stage to finished jewelry stage. So this photo has the circuit boards, the floppy disks, finished work, and then some of the electronic components that I like to use, like transistors, for example, in this picture. Those go on to become earrings and whatnot. So I'm very active online. I love showing process videos and photos, showing around the studio so you can get a sense for what I'm working with, how one thing becomes another. The processes I use, I tend to find are very not conducive to showing off in real time. It's not like watching an artist paint and then you see from start to finish. My processes are disjointed and batched, which is not interesting day-to-day watching. But I find that by creating videos, time-lapse videos showing stepwise what's happening, it's more interesting. And because it's not a process a lot of people do, and a lot of it was developed by me as I was just figuring out how to make stuff work, I think it's fun to follow along, and people really like it and ask for various photos of things and how things work. So if you want more of that, I post daily on Instagram and Facebook. So videos, photos, behind the scenes stuff, new stuff. And I also really love interacting with people. One thing COVID has really messed up is my ability to connect with people, which kind of is unfortunate as an extrovert. I love doing events where I can set out my work, show everyone what I've got, talk about process, show how it works, and then you actually get to touch it, move it around, and see some of the pieces have even like a cat's eye effect that gets lost in photos. So if you can't meet me in person, certainly not now, I encourage you to check out Circuit Breaker Labs on Instagram or Facebook so that we can continue the conversation there. And that's it for me.
Thank you so much, Amanda. So we're going to start the Q&A. If you haven't already, you can click on the bottom where it says chat and start typing questions in the chat, and I will read them to Amanda. So I'm gonna scroll up a little bit and see where our first questions were. Let's see, are there any dangerous materials in circuit boards that you have to avoid?
Most definitely. I imagine that question was asked before I got to it, but I'm happy to reiterate because it is so important. So fiberglass on its own isn't super dangerous, but as soon as you turn it into a dust-like material, it becomes like asbestos. So it's really important to protect your lungs and skin from that. Modern boards don't use as much lead on them anymore. Maybe it's even been legislated that you can't use it anymore. I'm not totally sure. But generally commercial electronics nowadays do not contain lead solder anymore. But because I don't know the vintage of the boards that I'm using, because they're all upcycled and I'm not about to look up every single serial number, I just assume they have lead. So I treat every circuit board as if it contains lead solder. Not to mention the other components on there will have heavy metals in them as well. The components soldered to the board itself. So if I treat every board as a hazard, I'm protecting myself. So all the safety equipment I have makes sure or ensures that how I'm handling them, I'm not ending those materials in my body or spread around the studio.
Okay. Next question, do you solder fine silver to capacitors, resistors, etc.?
Oh, that would be really fun. I don't know what metals are coming out of those materials, so you have to be careful about how you're soldering together. I imagine you could use tin solder to connect those components, but I've never tried it. There are other artists who work in those realms, whether they're making wearables or there's this gentleman somewhere in Europe, I think, who makes like mandala quilts out of these components. It's really cool. I wish I could remember his name to direct you to him. It's just one of those things that it's on the idea list. Someday I'd love to tinker around with it a little bit more technically than just wrapping them up. But for now, I'm just using them as like enhancements and fun little additions to the jewelry pieces with the circuit boards.
Okay. You mentioned the orange circuit boards were hard to get a hold of. Are there other really difficult things to get a hold of when you're making jewelry?
When it comes to circuit boards, there are certain colors that are even worse to find than orange, like white. Doesn't make a lot of sense to make a white circuit board. Part of the reason for the color, at least back when manufacturing was just beginning, was that it helped to also see what you were doing. So you could physically see if there was any defects on the boards, and the high contrast from the green color made that pretty easy to do. If you've got a white board, that's not so easy anymore. But with modern manufacturing techniques, it's not as much of a consideration. But because green has been around so long and has become the standard, it's usually the go-to, and any other color that ends up being used is just for a branding thing. Like Arduinos are blue, Raspberry Pis I think are blue. It's just the way they are. Certain boards are white. But what I'm finding is that most of them are in the like home electronics maker scene. So they're like really tiny boards. I only have one white motherboard sized piece. I don't actually know what it is, but it's not a motherboard. It's just the size of one. And I have been using it ever so sparingly. Most notably probably was in that custom piece I showed with the cactus. The moon was white. And so I have to be careful about saving certain things so that when the right project comes along, I actually have the materials to be able to do it. Another fun color that I haven't seen a lot of is sort of like a minty green with bronze tones. It's really pretty, but the boards are also only about this big, and I've only ever seen two. So I use them very sparingly and combine them with copper when I can to really bring out those warm metal tones. In terms of other stuff, I don't really use other stuff in like as intentional a way as with the circuit boards. The circuit boards are pretty much the bread and butter of my work. Almost all my work is circuit board. It's the other stuff that's sort of more tangential to what I'm doing. Mostly I like using it just as something different. So a different color, different shapes, different making techniques, just to keep me from being stuck in a rut, making the same exact thing over and over again. So for now, I'm not having a hard time finding other things that I specifically need to make that fit in with my existing processes. So it's mostly just finding circuit boards of the colors that I need.
Awesome. Let's see, I think we have one or two more questions. Do you have any pieces that were fails, but were perhaps also really satisfying?
That's a really interesting question. So when it comes to using the CNC, I alluded to this a little bit, where I have to be cognizant of the physical size of the bits that I'm using to cut and the design that I'm creating. And every once in a while, I'll sort of forget that and be reminded very quickly when maybe something's eyeball ends up being too big or falls out or something really silly like that. With jewelry making, especially earlier on when I was really figuring it out, a lot of it from the resin to cutting was still very rough and unrefined. So a lot of my early pieces looked really weird, especially because I didn't even know what bezels were, but I did know that you could cast resin. So my very first pieces incorporating circuit boards looked nothing like what I showed. I was actually casting them in molds. And the problem with that is that you can't see the front of the piece you're working on because you have to work from the back.
Right.
So bubbles would show up in weird places, or maybe the piece would be crooked. It was hard to tell. But some of that made it fun as well. I think that's getting to the other part of the question there, where there's always this anticipation of waiting for the resin to cure and then seeing what you get. Because if you use a clear mold, you can sort of tell what's going on. But even then, not really. You can't really see the edges very well. So popping them out of the mold is always like, did it work? Does this look cool? Sometimes it's a complete flop. Sometimes there's a bubble in a really weird spot that maybe actually adds to the piece instead of detracting from it. And sometimes it's just a mess and there's no way around it. But even those pieces, it always amazes me that I think maybe just because not many people work with circuit board, people don't even care. They're like, this is just so novel. I don't even care that there's flaws, or they can't see the flaws that I see. And that's a whole other conversation.
Mm-hmm.
So there's always that bit to it as well.
Awesome. Well, I think that's the end of our questions. So I guess I will start with the ending remarks. Thank you all for coming to the Maker Talk, and thank you, Amanda, for doing this.
Thanks for having me.
This talk is being recorded, as I mentioned. It's going to go up probably in a month on our YouTube. I'm going to post the link to our YouTube playlist where we put our Maker Talks. Part of the reason why it takes a month is because we have to type in all the captioning as well. But eventually, the link that I just posted is where it will be showing up, and you can watch other past Maker Talks in that playlist as well. Our next Maker Talk is going to be DIY zines. It's going to be done by artist Kat Brenowitz, and she's going to teach us how to fold a zine from a piece of paper and help you learn everything you need to know to design your own zine. You can sign up for that right now at our bit.ly, which I'm also going to put in there, which is bit.ly/labs classes. And that is about it. Thank you again. And thank you once more, Amanda.
Thank you.
All right. I'm going to end the chat now, and we'll see you guys at the next Maker Talk.